Welcome my friends to yet another video about primes, and today I'm going to show you how you can identify all primes up to 100 by starting out with nothing but a blank sheet, right? And as you can see, I have a writer document. I have arranged 3 columns in which I will write down the numbers. If you are writing by hand, you are of course enjoying much more freedom how to arrange the numbers, but all we have is a blank sheet and our theoretical knowledge about primes, and we can write them down. On the left hand side, I start out with 2 and the 3, which are of course the only primes outside of 6k plus minus 1. And as we know, all the primes greater than 3 are with necessity either of the form 6k plus 1 or 6k minus 1. So these are the next 2 columns in which I'll arrange the numbers. And as a mnemonic bridge serves the fact that 6 plus 1 equals 7, 6k minus equals 5. So we start out with these 2 numbers and then we simply add 6 until we reach our limit of 100, because in this video we want to identify all the primes up to 100. So most of the time we spend with writing down the numbers and not even with the computations themselves. This is funny, and this is just a reminder of the fact how easy it is, how incredibly easy it is to identify the primes. You know, there's no mystery about them. You don't need a sieve of Eratosthenes or anything like that. You know, you just need to write down the numbers like this. And then we have to perform 9 multiplications of the simplest form you can imagine. You know, 9 very simple multiplications. And as you will see, there are just 3 who are really who really matter, because now we are looking already at all the prime numbers, but in between them, you know, there are these sticky products hiding, and our task is now to identify the remaining products in between the primes. So our theoretical background is we do know that we can solely use these numbers to identify any remaining products. We don't need any other numbers outside of these 2 columns. This is incredible, I know, but it is fascinating and it is very powerful. So let's simply start out with 5. So we could easily erase all the numbers who are ending on the right hand side on 5, right? Because these are with necessity divisible by 5. But in this video we are just going very slow. So 5 times 5 equals 25. 5 times 7 equals 35. 5 times 11 equals 55. 5 times 13 equals 65. 5 times 17 equals 85. And 5 times 19 equals 95. So we already through with the 5 as a possible factor of the remaining products. So now we are going to the number 7. 7 times 7 is 49. 7 times 11 equals 77. And 7 times 13 equals 91. And as we can see, as we want to go further, 7 times 19, this already exceeds our limit of 100. And the same is true for 11 times 11, which equals, of course, 121. So believe it or not, you are already looking at all the primes up to 100. And we started out with a blank sheet, and most of the time we spent with writing down the numbers. This is how easy it is to identify all the primes up to 100. Thank you for watching the video, and until next time, bye.